Okay, in this video I'm going to start out, I'm going to show you how to find the derivative of y equal a to the x, where a is a base other than e. So there's two ways you can go about this. One way would actually be to write the right hand side. You can actually write a to the x as e to the power x times natural log of a. And if you read this up here, it tells you why you can do that. Now, if you take the derivative of both sides here, then y prime would equal, remember, now that I have this in the form of e to the u, then the derivative of e to the u is just e to the u, which would be e to the x times natural log of a, and then times the derivative u, which is the derivative of x times natural log of a. Now, since natural log of a is just a constant, so you're really just taking the derivative of a constant times x. And when you take the derivative of a constant times x, you just get the constant. So we get e to the x times natural log of a times natural log of a. And then we know from up here that since a to the x equals e to the x times natural log of a, we can replace this with a to the x, and we get y prime is equal to a to the x times the natural log of a. Now, another way you can show that, and I'll let you freeze the video and look at this one, but another way you could show it would just be to take the natural log of both sides. So if you take the natural log of both sides, you would get natural log of y is equal to x times natural log of a, and then if you take the derivative of both sides, the derivative of natural log of y is actually 1 over y prime, and the derivative of x times natural log of a is just natural log of a, and then multiply both sides by y, and you'll get y prime equals y times natural log of a. And since we know from up here y is equal to a to the x, then y prime would simply be a to the x times the natural log of a. So that leads us to these two formulas. The derivative of a to the x, where a is a number other than e, would actually be a to the x times the natural log of x. So for that formula, if I wanted to take the derivative of 5 to the x, I would actually just get 5 to the x times the natural log of 5. And then, of course, I also have the added to this tangent x, and of course the derivative of tangent x is secant squared x. Now, if this exponent is a function of x instead of x, then you have to apply this formula. So the derivative of a to the u, you would actually have three factors. You would have a to the u, that should be a u right there, by the way. So you would have a to the u, then you would have times the natural log of a, so that's really messed up, that should be a, and then times u prime. So let me pause just a minute and fix that. Okay, so that got out of whack, so I fixed it for you. So the derivative of a to the u is actually a to the u times the natural log of a times u prime, where u prime is just the derivative of u with respect to x. Okay, so let's take a look at an example here. Here I have y equals 7, so a is 7, and u, the exponent, is x cubed minus 2x. Blow that up just a little bit for you. So now you've got 7 to the u. So the derivative, using this formula up here, you would go ahead and copy the entire function down first, so that would be a to the u, and then you would multiply by the natural log of the base here, so by the natural log of 7, and then you would multiply that by the derivative of the exponent. So the derivative of x cubed minus 2 would be 3x squared minus 2. So again, there you have three factors that you would have there. Okay, so now let me go ahead and look at this one. Here the a would be 2 and u would be the sine of x squared. So now we have to be careful on this one, but first of all, you still use the same formula. The derivative of that would be a to the u, so it would be 2 to the sine of x squared, and then multiply by the natural log of a, so a would be 2, so that would be times the natural log of 2. Okay, then you multiply by the derivative of sine of x squared. Okay, now remember, the derivative of sine u is actually cosine u, so we would have cosine of x squared, But then remember, you have to multiply by the derivative of this argument here. So then we multiply by the derivative of x squared, and that's where the 2x comes from. Okay, now if you integrate a to the u du, you actually would get a to the u divided by natural log of a plus a c. Okay, but you've got to make sure that your integral is actually of the form a to the u du. So let's take a look at an example. So here I've got 4 raised to the tangent of x times secant squared x dx. Okay, so here a is 4, and so I would have to let u would have to be the tangent of x, the exponent there. And then if this part right here turns out to be du, then I'm in good shape. So let's see what du is. Du would be the derivative of tangent, which is secant squared x times dx. So that's exactly what I have there. So actually, I do have this in the form of the integral of 4 to the u du. And based on this formula, it would be equal 4 to the u over the natural log of 4 plus a constant. But since I know u is tangent of x, that would actually be 4 raised to the tangent x power divided by natural log of 4 plus a constant. Okay, let's do another one here. Alright, so now here I have x squared times 2 to the x cubed dx. So since I have 2 raised to the x cubed, I'm going to assume that a is 2, and so I'm going to try to get this in the form of 2 to the u. So if I want this in the form of 2 to the u, then u would have to be x cubed, and then du would have to be 3x squared dx. Okay, so I don't have the 3, but I do have the x squared dx. So what I would do is I would put in the 3 right here and then multiply the outside by 1/3. So now the 3x squared dx, that acts as the du, and then 2 to the x cubed acts as the 2 to the u. And so now to integrate 2 to the u du, that would just be 2 to the u divided by natural log of 2. And then of course I have a 1/3 out here, so I'd have to multiply that by 1/3, and then of course add your constant. And then the last step is to go ahead and replace u with x cubed. So I get 2 to the x cubed over 3 times natural log of 2 for the final answer. Okay, let's talk about log of x base a real quick. Log of x base a and a to the x are inverses. Therefore, if I took a and raised it to the log of x base a, I would get x. Or if I took the log of a to the x base a, I would get x. So you can actually get a change of base formula. So let me show you this. If you have y equals the log of x base a, you can actually write this in exponential form as a to the y equals x. And then you could take the log of both sides. So natural log of a to the y equals natural log of x. And then you could write natural log of a to the y as y times the natural log of a. And then divide both sides by natural log of a. And you get y equals natural log of x divided by natural log of a. But remember, y is equal to the log of x base a. So actually it turns out that you can write the log of x base a as the natural log of x over natural log of a. Actually, you can use any log when you write this ratio, but since we have natural log on our calculator, it makes more sense. So I'll just do one of these, and then you can look at the next one. So if I wanted to figure out what is the log of 300 base 5, I could use natural log in the change of base formula and write that as the natural log of 300 divided by the natural log of 5. And then you could just put that in your calculator to get the answer. I didn't simplify it for you or get you the numerical answer, but you can. And then you can look at example 2 on your own and see that I basically did the same thing on that one. Okay, so if you wanted to take the derivative of log of x base a, that would be 1 over x times the natural log of a. But if you wanted to take the derivative of log of u base a, where u is a function of x, then that would be 1 over u times natural log of a, and then you would have to multiply by u prime or du over dx. You can look at the proof there, but I'm not going to take the time to go over the proof. So I'll do the first example here. I'll use the simple formula. So in the simple formula, you just have log of x base 3. So based on this formula up here, that would just be 1 over x times natural log of 3. Okay. Now this one is log of u base 3. So on that one, I would use the second formula here. So that would be 1 over u. So it would be 1 over u. So 1 over the argument there. And then times the natural log of the base, which is 3. And then you multiply by the derivative of this argument, which is 6x minus 5. So that would give you 6x minus 5 over 3x squared minus 5x plus 1 times natural log of 3. So that's how you take the derivatives of logs that use a different base. Okay, since the log function is so closely related to the natural log function, I don't really have any integrals for you that that you would integrate, and then you would, such that you would end up back with one of these logs of a different base, because you actually wouldn't end up with those logs. You would end up with some form of natural log, because these guys can be written as natural logs. So I don't really have any integrals here for you here, but what I did want to show you, just to show you that if you wanted to integrate the natural log of x dx, then there is a formula for that. I'm not going to show you where it came from, but the formula for that would be x times the natural log of x minus x, and of course plus the constant. So that's the formula for integrating the natural log of x. Now let me show you what would happen if you integrated a log of a different base. Okay, so let's say you wanted to integrate log of x base 3. Well, you don't really need a formula for this, because actually you can use the change of base formula, and you can write this as natural log of x over natural log of 3. And since natural log of 3 is a constant, you could actually factor out the 1 over natural log of 3 out of the integral, and you would just be left with natural log of x dx. And then we have a formula for that. Remember, I just showed you that. So if you integrate this, you just get x times the natural log of x minus x, and then you would multiply it by 1 over the natural log of 3, and then add your constant. So even though I don't have any integration to show you that leads back to these logs of different bases, obviously there are formulas that can be used to integrate log functions, whether it's natural log of x or whether it's log of x using a base other than e. Okay, so on the next video, I'm actually going to show you a few examples of applications that are related to these logs and exponential functions. So I may not show you every example, but I'll show you a few in the next video.